Hey everyone, happy Thanksgiving. I'm gonna do this cool demo right before the Thanksgiving. Today I'm gonna use the Alexa to trigger the automation with Direct Connect into your Transit VPC. So it is a very cool demo. And Alexa will trigger a Cloud Formation template that will provision in the CSR and also your on-prem ASR. So let's go straight into the demo. Alexa, ask Direct Connect.
Welcome to the Alexa AWS Direct Connect. You can ask me your Direct Connect service and deploy it with your current Transit VPC.
Get my Direct Connect connection.
Your available Direct Connection ID is XCON FAH5S1VSJ.
Deploy it.
Your Direct Connect has been deployed. Please go to your AWS console to check.
Okay, let's check on the Cloud Formation GUI. As you can see, the Direct Connect Cloud Formation template has been triggered. So let's switch back to my laptop for detailed information. Okay, we got back to my AWS console, which is showing on my laptop. And I have two CSR running, and I will go through the topology later. But basically, we have a Transit VPC running, and we have the CSR, which already connected to a spoke. So if you do a show IP interface brief, you already see, okay, I have already connected to a spoke, and the spoke side subnet is 20 subnet, and later you are gonna see multiple tunnels will be spin up because the Cloud Formation template is doing a lot of automation in the background. Like it's gonna create a virtual interface, it's gonna create a VGW, it's gonna build the BGP between your ASR router to your VGW, and then build another overlay from the ASR to the CSR. It will take around 5 to 10 minutes for all the infrastructure bring up. But we can do a very quick check on the Direct Connect side. I have a connection available, which is exactly the same connection Alexa told me. And then if I go to the virtual interface, you can see the virtual interface has already been created and it's in the pending state. If we go back to the Cloud Formation template side, it's still creating, and you can check what is the smaller. You can check what is the event that is going on. Let's give it a couple minutes. When all the automation has been done, we'll come back and I will walk you through what are the components that this Cloud Formation can help you create. Okay, while we are waiting, let's talk about the design we have today. So I guess you have two options to connect your Direct Connect into your Transit VPC. You have the first option, which is called detached VGW. You create a virtual private gateway, but you don't attach to the Transit VPC, while it will terminate the direct connection at the other side. The benefit of doing this design is you can leverage the current Lambda function in the Transit VPC. You give the VGW the same tag. It's gonna treat that VGW as another spoke. So tunnel will be created from the CSR to the VGW, and then the automation will be done. The routing will be done. So there will be two BGP connections, between VGW and the CSR, and also between VGW and your ASR1K, which sit on your on-prem network. The downside of this solution, or the limitation of this solution, is currently VGW only support 1 gig. And AWS is improving the throughput at this moment, but while the VGW is doing encryption, you will be limited to 1 gig. So this is the first solution called detached VGW. If you have running a 1 gig Direct Connect or sub 1 gig Direct Connect, I think this will be the perfect solution. The other one is called the attached VGW. The main idea to attach the VGW to the Transit VPC is to make it transparent to the overlay. After you attach the VGW to the Transit VPC, the CSR can talk to ASR directly, and then they can build tunnel. You have the option to do non-encryption, so you can do a GRE from CSR to ASR. You can do IPsec if you need encryption. The benefit of doing this design is it will remove the VGW from the IPsec function. The CSR will be doing the tunneling from to the ASR directly. So you should be able to go up to 5 gig on each of the CSR and then 10 gig to utilize your 10 gig direct connect pipe. The downside of this solution is we don't have automation yet, or technically till now. You have to build this more like manually. I have a video about how to build this manually. It's around 30 to 40 minutes. I guess not everybody enjoy the manual configuration. They want automation, so that's why I record this video. So let's take a look what is the automation for attached VGW. So first, you have to deploy a transit VPC, which means you have to have a transit VPC running. Then you have to talk to your service provider to provision your direct connect connection, so you will be able to know what is your direct connect connection ID. The third step, you have to launch the transit VPC direct automate Cloud Formation template. So basically, you have to specify what is your transit VPC S3 bucket, which I explained this in another video. So you have to input those S3 bucket to the direct connect automation Cloud Formation template. You have to put the connection ID, which you will get it from the step 2. You have the option to go with VGW or direct connect gateway. That's a new feature AWS announced a couple weeks ago. And then you have to know what is your on-prem side, right? You have to provision your on-prem router. So here, if your on-prem router has internet access, the Lambda function triggered by the Cloud Formation template will be able to provision your on-prem router. If it doesn't have internet access, the Lambda function will be able to save the configuration that need to be applied to the router on S3 bucket. So what you need to do is you can just send that S3 bucket to a network admin sitting at the data center, and he will be able to copy and paste the configuration to your ASR, and then the overlay will be built. If your ASR is also available from a jump server, you can also do a jump server nested SSH, which the Cloud Formation will do it for you, and that's what I'm using in this demo. And the number 5, actually, it is all being done from the Cloud Formation template and the Lambda. So it's gonna create an S3 bucket containing all the metadata information. A VGW or DCG will be created based on your option, and a virtual interface will be created as well. The S3 bucket will put event trigger, which will trigger a Lambda function. Basically, it's gonna provision the first BGP connection between your ASR and the VGW. The second, and it's gonna enable IPsec tunnel between the ASR and the CSR. It will provision another BGP connection between your ASR and the CSR, and then the ASR configuration, also the CSR configuration, will be saved to the S3 bucket. That is very useful if your ASR is not public reachable, and the customer can copy and paste it. And here is exactly the same setup I have done for the other video, which is more like manually. Now I have it running already connected to a spoke. So I have a 20 subnet or 20 setter block spoke connected already. So it's gonna create the first BGP connection between the ASR and the virtual interface. And by the way, the virtual interface will also be created by this automation. So it's more like a greenfield deploy. You don't have to worry about any heavy lifting, bring up. And then it will create the loopback interface on the ASR. It will create the IPsec tunnel from the ASR to your CSR using that loopback IP address. And then it will enable the IPsec, also the BGP. So that's basically what the template and the Cloud Formation or the Lambda will do for you. So let's check if the tunnel is up. Okay, let me go to, as I mentioned before, right? There's only 2 tunnels before we deploy the template, and now we have 3 tunnels. And also we can do a show BGP all. And by the way, this tunnel is the tunnel that goes back to your ASR, which you are using overlay. If you show BGP all, you can see these 10, 11 routes are the on-prem routes. And in the template, you can define what is your on-prem route, and it will be advertised into the BGP automatically. So this means the route has been advertised to the CSR in the transit VPC already. That's the on-prem route. If we do show IP BGP summary, show BGP summary, BGP all. Okay, so that's all the routes you have. Okay, so this show BGP all summary will tell you what are the neighbors you have. So you have one neighbor that goes back to your on-prem router, which is 99.0.2.1. You have 2 other neighbors, that is the VGW, because VGW is a logical concept. It has 2 endpoints. So this is basically tell you the overlay network has been set up. And let's log into the on-prem router and do a connectivity test. So this is my jump server, and then let me log into my CSR. This is the CSR, or actually this is the ASR running at on-prem. And you can see there are 2 tunnels configured. Tunnel 1 goes to transit CSR1, tunnel 2 goes to transit CSR2. If you do a show IP route, you should be able to see this 20 subnet has been learned from the BGP, which is one of the BGP neighbor. I have a VM that's running here. This is my VM that's running in a spoke, and the IP address 20.254, and we can try to, let me do a show IP interface brief. And this gigabit 1 is one of the on-prem routes or the on-prem subnet. So let me just ping 20 subnet source gigabit 1. You can see it can reach out to the spoke side, which means the connectivity has been brought up by this automation. And we do a trace route. We can do another source gigabit 1. And this will tell you what are the hops it reaches. So you can see it's gonna go to 99.0.1.2, which exactly is the transit CSR2. If we go back to the setup, 2.subnet, right? Sorry, 1.subnet, which is this one, 1.2. And then it can reach out to the spoke VPC, and then reach out to the VM. So this is a very quick demo how to deploy the direct connect circuit with your current transit VPC in like 5 to 10 minutes with all the automation. And let's take a look what are the template looks like, and also what are the automation looks like. So let's go back to the Cloud Formation here. As you can see, it's already create complete. Let's deploy the template manually, or let's go through what is included in this template. This template can also be found at my GitHub, and also I'm gonna push all my Lambda functions to the GitHub as well. So you need to define what is the stack name. You need to define what is your direct connection ID. So basically, you can just copy the direct connection ID that is available in your direct connect console, and then copy the paste here. Then you have the option to choose if you want to deploy as a VGW, or if you want to deploy as DC, the direct connect gateway. I'm not going to talk about the difference between those two. There's a lot of documentation, but basically DCG is more scalable than the VGW. But in this demo, I'm still using the VGW. The VGW doesn't support customized BGP-AS number, so I put it as a fix, 7224. And this AWS IP address will be the IP address for the Direct Connect, which is sit on the VGW side. The customer IP address actually will be the IP address you configure on your on-prem router, and it has to be a /30. And those came up with by default default value, so I predefine those values. Typically, you don't have to change those unless those 99 IP addresses are being used in your network, but you can just change those IP addresses based on your scenario. As I mentioned, on the data center side, you need those information. Basically, you need to tell the automation what is the physical interface on the ASR that is connected to the direct connect circuit. The loopback IP address, as I mentioned, you don't have to change it unless the 99 IP address has been used in your network. The BGP-AS number, you have to match what is the BGP-AS used on your ASR. Also, those data center route prefix, you can put multiple route just by using a comma to separate those different routes. And the following section about the public IP of my jump server, username of my jump server, those are only required if you have a jump server which can reach out to the ASR. So you need to put those information. So basically the CloudFormation will trigger the Lambda function, which will do a nested SSH. So it's going to SSH to the jump server first, and then do another SSH to the ASR from that jump server, and then push the configuration. If the ASR can be accessed directly, you can just ignore the part of the public, the jump server, and just put the value for the ASR, and the Lambda function will log into the ASR directly. If you didn't put anything, basically it will not log into the ASR, it will just push the config to the S3 bucket, which I will show you later. And then comes to a transit VPC CSR. That is basically you need to tell the automation which CSR I want to provision, which transit VPC I want to provision. And this bucket, you can get it from the previous Cloud Formation template. So if we go to your Cloud Formation template here, as you can see, I have a lot of transit VPC deployed. Let's take a look at this key transit VPC. If you click the resource, or you click the output actually, the config S3 bucket, this is the one you need to copy. So you have to find which transit VPC you want to deploy with the Direct Connect. Go to the Cloud Formation template, click the outputs, copy this config S3 bucket value, go back to the template again, paste it here. The prefix is exactly the same. This is bucket prefix. You have to copy this one and paste it here. And then, because there will be a VRF created on the CSR to represent your on-prem connection, so this DX is also predefined in the template. You can change it based on your requirement. And the last section is the tunnel configuration between your data center ASR and your transit VPC CSR1 and CSR2. And those are only used locally to establish the tunnel and also enable the BGP neighbor. So unless your 99 IP address has been used, or you don't want to use that IP address, you can change it. Otherwise, you can just keep it. And then you just click next. And then you select acknowledge. Let's see. Then you select the acknowledgement, and then you can just deploy. Since I deployed it with my Alexa, I don't have to deploy it again. If you click this template, ideally after it has been successfully deployed, if you click this output, you'll get the same or something similar. It's going to create S3 bucket. So if you go to this S3 bucket, that is the S3 bucket I mentioned before, which stores the configuration pushed to the router. So you can copy the configuration and go to your ASR deploy. So search here. This is the bucket. And you can find out there are 5 files here. Let's take a look at this DX metadata configured txt. What does it mean? So as you can see, this is just basic my information I input in the template, which has been stored on S3 bucket. So what is the CSR IP address, which is dynamically gathered? What is the username I put here? What is the tunnel IP address? So this is the metadata information. If we go back to the S3 bucket, so you can see 2 configuration will be pushed to your ASR, including ASR to the virtual interface. That's the first BGP, as I mentioned. And the other one will be ASR to your CSR, that including the tunnel, the second BGP, and also the CSR configuration, which is mainly the tunnel goes to your ASR and the BGP. So let's click one of the VIF, try to see if you can just copy and paste it. Let me open my editor. So this is just general or normal IOXXE command. I also made the format red for you, so you can just basically copy it and paste it on your ASR. And you can download the other one to check the ASR to CSR configuration, which are including 2 tunnels, the IPsec, and also the BGP. So those are the IPsec policy put here, and also the tunnel configuration, 2 tunnels created, and also the BGP. And those parameters are dynamically gathered from the Lambda function. Okay, so this is how the Cloud Formation template works. And let's take a look at the Lambda. If we click the Cloud Formation, which should be here, if you click resource, you're gonna see a couple Lambda functions. Those custom Lambda functions are those dynamically triggered during the Cloud Formation template creation. So basically, it's gonna gather some metadata information. Those are you don't have to worry about those. This one you should take a look, which is called DX connection, and this is the focus of the Lambda, which will push the configuration. I don't think it's gonna show up the code here, but basically you can download it, you can export the function, and then you will see a couple. Download developed package. It's around 20 meg, I would say. And then if you double click the folder, this is exactly what is required in I use, the library I've used. And the code, it sits in the DX connection by PY. If you use this to open. So this is basically the code I've read. And you can see this is just to create the configuration. If you want to add something, you can just change the code and then save it, compress into another zip, upload to the Lambda, and that's it. And you can also see from the monitoring perspective, it has been triggered once, because that's the time I deploy it. There's no error. And you can just view logs in the CloudWatch. This is the watch, and you can see there are some information printing out. Basically, if you start, actually there's a lot of log. I made it available for the debug, but if you start, just search for start. Or actually it's starting. Okay, let's do this. So it will tell you starting to configure ASR to VGW. So it will create the first BGP and it will send the configuration. You can see after you send the configuration, it's gonna save the configuration, copy, run, start. And it will tell you starting to configure the ASR to CSR, which will basically will create IPsec tunnel, enable BGP. Then it's gonna configure the CSR1 to ASR, IPsec BGP again, CSR to ASR. So exactly the same thing. Okay, I think you probably already understand how this is being done through the Cloud Formation and Lambda to connect the direct connect with your transit VPC. If you are interested in this automation, please send an email to ask-csr-aws-pm, and I will share the code with you so you can deploy it in your account. In the meanwhile, let me tell you what are the steps or works you have to do before you deploy the solution. So basically, this is my GitHub link. After you contact me, I will share the code here, but you need to follow these instructions. There are 3 key parts which are required to deploy the solution. The starting point is the Cloud Formation template, which is show up here. It's a JSON file. It's gonna bring up the Direct Connect. It's gonna create overlay. Currently, we only support ASR1K or ASR4K that are running at the on-prem side. The second thing you need to do is to zip all the files under DX connection folder. So those are the necessary library the DX connection use. Basically, we will push the configuration to the CSR. So we are leveraging the Paramiko library, so which include a lot of things here. So basically, you need to zip all the file under this folder. But please do not zip that folder. Zip all the file under here. So the Lambda function knows exactly which file to call the function. Name it as zip connection.zip or any name you want. Second, follow the same way to zip all file under DX solution helper. The solution helper basically is to create a custom Lambda function in the Cloud Formation template. For example, we will retrieve the IP address, retrieve the username, retrieve the private key from the S3 bucket prefix you put in the Cloud Formation template, and then we will store those information to a metadata S3 bucket, which you already see in the previous section. So please remember to zip all the files under the folder. Do not zip the folder directly. And then you need to create your own S3 bucket. For example, DX automation, your AWS account ID. And you need to host the scripts or the zip file where Lambda function will use. Let's use DXCon automation -fyng2 as examples. That's exactly the folder I have. If we go to my S3 bucket, actually this is exactly the one I'm talking about. You will create the DX connection folder, which basically will host that zip file you created. This is some file I created before. I didn't follow the name instructions. Another, you have to create the DX solution helper, which will have this another file. You can ignore those templates and DX perm. They are not necessarily used in this demo. And then after you create those 2 folders, you need to upload the DX connection zip file, which is done in the step 2 to the DX connection folder, and upload the DX solution help zip file, which is done in the 3rd step to the correct folder. And then you need to change or modify your DX solution, DX transit VPC template, which is Cloud Formation template, to use the zip file in your S3 bucket. So you need to find the following sections. Basically, we have 2 Lambda functions, and because there are 2 folders, right? So if you find the first part, which is DX connection, you need to change the S3 bucket to the S3 bucket you created. And just change to the S3 bucket you created in the previous step. Also change this key, including the folder name with the slash and the zip file name. And this is for the DX connection Lambda. As I mentioned, there's another one called DX solution helper. So you need to find this section in the Cloud Formation template, and then change this S3 bucket to the same S3 bucket in the above section, which is the one you created, and also change it to DX solution helper, the folder name, and with the slash and with the zip file name. That's it. What you need to do to deploy this solution in your environment. Also, if you are interested in how to set up the Alexa to trigger the Cloud Formation, or theoretically it's triggering a Lambda function, then trigger the Cloud Formation, please let me know as well. The last but not least important thing is Happy Thanksgiving.